Hello, 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 hello. Hello, 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 hello. So, hello, my dear students. Welcome back to this new series that is our fast track series, right? So, basically, in this series, we are going to complete some major portions of physics from the 11th class and from the 12th class. So, in this lecture, we are going to start the ray optics from the 12th standard and hello, beta, hello, hello. Yeah. So, we have some students with us, right? And one of my old students is Jasif, and he's telling me that this please motivate me, right? Okay, okay, clear. Okay, I think we need to start now, right? I think we need to start now. So let's start. Hello, 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 Arushi. I guess we need to start now, right? Okay, so let's start. Okay, that's great. And we will start. Just give me 1 second. Okay, 1 second. Okay, so the first thing that we will discuss in this particular lecture that would be the refraction, right? So we are Avina, hello beta. So we are going to start the refraction of light. So we are going to start from the very beginning of the optics, and we will start ray optics, right? We will start ray optics, and we have different topics from ray optics. But the first topic that we will start in this particular session, that is our refraction. Okay, so let's start the first topic. That is what refraction. That is refraction, and you all are aware of this topic's name, that is the refraction, right? So we have done the same thing from the 11 from the 10th physics, right? So what is refraction? Refraction simply means the bending of light ray. Refraction means the bending of light ray when light passes through two different mediums having different optical densities. Okay, so what is refraction? It is simply what? A phenomena in which bending happens. It is bending of light. Bending of light. Bending of light ray when it travels from denser medium to denser to the rarer medium, or rarer to denser medium. So a phenomena occurs when light travels from denser medium to rarer, or from rarer to denser. That phenomena is known as refraction, the bending of light ray. Bending of light ray. Okay. Now, suppose we have two mediums separated by this line. Okay, this is an imaginary line or known as a plane. Okay, so let's suppose a light is incident on this plane like this. So we have to draw a perpendicular line to this plane. So this perpendicular line is called normal. This perpendicular line is known as what? Normal. Clear? This is first medium. This one is medium first with a refractive index new one. What is new one? It is the refractive index of medium first. This one is what? A refractive index. Later on, I will discuss what refractive index is. Okay, refractive index of medium first. Medium first. So this is this line known as incidental ray. This is what? Incidental light ray. And the angle between the incidental light ray and the normal is known as what? Angle of incidence. This one is known as what? Angle of incidence. So when light travels from one medium to the second medium second, and this medium second is having a refractive index. This one is having different refractive index. There should be a different refractive index, right? Refractive index of mu2. Mu1 and mu2 is a notation, notation used for what? Refractive index. Okay. So now this light suffers a deviation. This light suffers a what? It suffers a deviation. Okay. Let's suppose it suffers a deviation like this. Okay. This is not good. So I will make by my own bare hands. So it will suffer a deviation like this. So this deviation, this bending of light ray is known as what? Refraction. Okay. So this ray that comes from the first medium, okay, that is in the second medium is known as what? It is a refracted ray. This one is known as what? A refracted ray. And angle between normal and this refracted ray is known as what? Angle of refraction. Angle of refraction. So this is what? A sum up of refraction. This is what? A sum up of refraction. Okay. Okay. 1 second. Okay. It's angle of refraction, right? So look, incidental light ray, we know it. Angle of incidence, we know it. Normal, we know it, right? Refracted ray, angle of refraction, refractive index of second medium. We all are aware of all these terms from the very beginning of 10th standard. Now, let us revise what refractive index is. Let us revise what refractive index is. So, a refractive index. So, refractive index is the ratio of speed of light in a vacuum to the speed of light in medium. Okay. So, refractive index is mu, which is equals to speed of light in vacuum divided by speed of light in medium. Okay. So, I will write now. What is C? It is the speed of light. Speed of light in vacuum to speed of light in any given medium. This ratio is known as what? A refractive index. As you can see here, we have two different mediums, right? One is vacuum and second is some different medium. Okay. If now medium first is fixed, that is vacuum or air, so we have a specific name for this ratio. And the specific name is what? Absolute refractive index. Absolute refractive index. So what is absolute refractive index? In which one medium is what? Air or vacuum. in which one medium is air and vacuum. So we may call that type of refractive index as what? Absolute refractive index. Absolute refractive index, right? Okay. Let's suppose we have two different mediums now. We don't have an air or a vacuum now. We have a two different mediums. Let's suppose we have a glycerine, we have a glass, we have a water, we have a kerosene. So we have a two different mediums, except we don't have any vacuum or air present, right? So we may call this ratio as a relative refractive index. So we have a second term known as relative refractive index. Relative refractive index. So what is relative refractive index? I can write here, right? It is what? Speed of light. Speed of light in medium first to speed of light in medium second. Clear? This is what? Relative refractive index. Relative refractive index. We may have different ways to represent it. We may have what? Different ways to represent it. What? Refractive index. Done? Let us suppose we have to express the relative refractive index in terms of nu. How we can represent it? How we can represent it? Let us suppose we have to find out relative refractive index of second medium with respect to the first medium. We have to find out refractive index of second medium with respect to the the refractive index of first medium. So I can write mu to 1, that is light is coming from 1 and goes into the second medium, so we may call it as a refractive index of second medium with respect to the first medium, and we can express the same thing in this kind of notation. So I can write here what? Refractive index of second medium divided by refractive index of first medium. So now how we will read it? It is a refractive index is what? A refractive index of refractive index of medium second with respect to medium first. With respect to what? Medium first. This is how we can represent what? Relative refractive index. This is how we can represent what? Relative refractive index. So let us suppose we have a refractive index, right? We have Ri means refractive index. We have a refractive index. We have a refractive index of, let's put glass. So a refractive index of glass. And a refractive index of glass is given to be 3/2. One more, we have a refractive index of water, and it is given to be 4/3. These are absolute refractive index. Example of absolute refractive index. That means if a light is coming from the air or vacuum, goes into the glass, the refractive index we get as 3/2. And if the light is coming from the vacuum, goes into the water, it is refractive index is 4/3. Done? Now, if I ask you, just give me the refractive index of glass. Give me what? Refractive index of glass with respect to water. With respect to water. Refractive index of glass with respect to what? Water. So how I can write it? So we know it. We have to write nu. Refractive index of glass with respect to water. I can write refractive index of glass with respect to water. So glass is how much? It is 3/2. And water is how much? It is 4/3. I guess I will get 9/8. Okay. So what is 9/8? 9/8 is the refractive index of glass with respect to the water. With respect to the water. Done? Easy? Okay. Now let us suppose we have a different now. Okay, so we have done this one. Now let us suppose we have a different aspects of it. Let us suppose we define or we discuss now refractive index based on the speed alteration, based on the speed fluctuation. Okay. So suppose we have a medium. We have a medium. And in medium, let us suppose we calculate the speed of light as v, and v is given to be 2 into 10 to the power 8 meters per second. Okay, we have a medium, we have a medium, and in the medium we observe the speed of light to be 2 to power 2 into 10 to the power 8 meter per second, and we have to find out what should be the refractive index of this particular medium. What should be the refractive index of this particular medium? So how we can get it? We know that a refractive index is nothing, it is a ratio of speed of light in vacuum to the speed of light in medium. So I think we can write now it is 3 into 10 to the power 8 divided by 2 into 10 to the power 8. Cancel out. So my refractive index of this particular medium came out to be 3 by 2. It came out to be 3 by 2. Done. So this is how we can get different different ways to represent my refractive index. Okay. So by doing this now, you can define all these factors, right? By doing this, you can define all of these factors. Easy, very easy, right? So I am just teaching you from the very basics. It is very basics. I guess many of you have done the same thing in the 10th standard. Okay. So let's take one more example. Suppose we have a medium. We have a medium first and medium second. Medium first is oil. Medium second is glycerin. And the refractive index of oil would be mu oil. And refractive index of glycerin should be mu glycerin. Clear? Mu oil and mu glycerin. Now what we need to find from this particular example, we have to find out what? Give me a second. We have to find out a refractive index of oil with respect to glycerin. How we can write? We can write simply a refractive index of oil with respect to glycerin. This is how we can represent these things. This is how we can represent these things. Okay? Easy? Very easy, no? This is all about the refraction. Now coming to the laws of refraction. Coming to the laws of refraction. Now you have to put the heading of laws of refraction. Laws of refraction. And we all are aware of the fact that refraction is having two laws. Refraction is having two laws. So we have two laws. First law. And what is first law? And first law states that the incidental ray. Okay, I will write it. Huh? I will write firstly. The incidental ray, refracted ray, incidental ray, refracted ray, and the normal, and the normal to the interface, of two media. Interface of two media all lie in the same plane. In this same plane of incidence, right? So the first law states that the incident ray, the refracted ray, and the normal to the interface of the two media. What is interface? Interface means this line. Okay, this is the interface. So all lie on the same plane. Very easy. It is not an important one, but a second law is very important to us. Second law is very, very, very important to us. And second law is what? Snell's law. It is Snell's law. Okay. Now, what Snell's law is all about? Let us suppose we have a refraction like this. Let us suppose we have a refraction like this. Look now. So we have a refraction like this. Okay. And light is coming from a one medium. So my light is coming in this way. And it gets refracted like this. And we all are aware of the fact that, just give me 1 second, that this angle is known as angle of incidence and this angle is known as angle of refraction. Okay. And it the first medium, now it is first medium and this one is second medium. First medium is having a refractive index mu1. Second medium is having a refractive index mu2. According to Snell, it states that mu1 sine of angle of incidence should be equal to mu2 sine of refraction. This is what? Second law of refraction, known as Snell's law. Known as Snell's law, and it is one of the important formula in your whole ray optics. Without this, you cannot do a single numerical from the ray optics. Okay? It is mu1, simply what? It is a mu1 into the angle that it is having, right? This one. And mu2 with this angle. It should be constant. Mu1 sine I equals to mu2 sine R. This is Snell's law, right? Let us suppose we have a something like this. Let us suppose we have a something like this. We have a something like this. This is normal to the interface. This line represents is normal to the interface. Now a light ray is coming in this way. It gets deviated from its path. Okay. So let us suppose this angle is alpha and this angle is beta. Suppose this angle is alpha and this angle is beta. The refractive index of first medium is nu naught. Refractive index of second medium is nu dash. How you will represent the same thing into Snell's law? So this is what? A point where refraction occurs. So you need to just multiply the upper terms and equate them with the multiplication of the lower terms. So how we can write it? It is nothing but nu naught sine of angle of alpha should be equals to nu dash sine of angle of beta. Okay. This is how we can use what? Snell's law. This is how we can use Snell's law. Easy? Very easy, right? Okay. So now up to now we have discussed how refraction occurs. We had discussed the different terms related to the refraction. We discussed the laws of refraction. Now coming to the very important topic known as multiple parallel surface refraction. Let us suppose we have now multiple surfaces. We were discussing refraction now by only one interface. This was one interface, light is coming in this way and it gets deviated. So it was only one phase, one single phase, right? Now let us suppose we have one phase, one medium, second medium. The second phase, one medium, two mediums, and three mediums. So we have a two phases, right? And these phases should be parallel to each other. Now we have a different phases like this. Now what? Where have we have now a different phases like this. So you need to write now the topic name known as multiple parallel surfaces. It is what? Multiple parallel surfaces. Multiple parallel surfaces. Okay. Suppose we have something like this. 1 second. This should be visible to you. Now we have something, one surface. Okay. Or we can do one thing now. I can just make like this now. One surface. second surface like this. Then we have third surface. We have then what? Third surface, and so on, and so on. Okay, and so on. Let us suppose a light is coming like this. Suppose, no? Suppose the light is coming in this way. Okay. Now, what we have to do? We have to draw a normal to it. We have to draw a normal to it. Clear? So this is what? Angle of incidence. This is what? Nu one. A refractive index of first medium, a refractive index of second medium, a refractive index of third medium, a refractive index of fourth medium. Now after this, I think light will suffer a refraction like this. Okay. Now same what we are having now, we have to plot a normal to it. Now it will suffer one more refraction. It will suffer one more refraction. One more thing, it will suffer a one more refraction. Now like that, it will suffer a one more refraction. Okay. Okay. So how many refractions? One refraction, two refraction, and third. So this third, this is angle of emergence, E. Let us zoom it now. Okay, now I need to zoom it so I can make you understand about it, alright? Look now. Look now. So if this is angle of incidence, so this should be angle of refraction. And if this is angle of R, this should be also angle of R. Okay, same property. Now this is angle of incidence for this medium, so we have now angle of refraction R1. If this is R1, so same, this should be what? R1. Okay, now below it, so now, and it is, okay, so we have just give tagging to all of these angles, right? So now we can apply Snell's law to each and every point where refraction occurs. That means we can apply Snell's law here, we can apply here, we can apply here, and so on. So for the first one, for the first surface, how we can write Snell's law? It is nu one sine of I equals to nu 2 sine R. It is what? Nu 2 sine R. Now second refraction. At this particular point, I can write mu 2 sine R equals to mu 3 sine R1. It is what? Mu 3 sine R1. Third phase, I can write mu 3 sine R1 equals to mu 4 sine E. Okay. So by this way, you can conclude that, you can conclude what? You can conclude that mu 1 sine I is equals to mu 2 sine R, and mu 2 sine R is equal to how much? It is mu 3 sine R1, and mu 3 sine R1 equals to mu 4 sine E. So therefore you can write mu sine of incidence is constant. Okay, this is also asked in the Olympiad examination. It is mu sine I equals to constant. So if you have this sort of problem now in your paper, you don't need to write each and every step. Okay, just focus on the steps where refraction occurs, and it occurs here. Now it is, this refraction is equal to this refraction. This is also equal to this one. And if we have to relate this refraction with this one, we can easily relate these two things. Why? Because we have done it now. Okay, so we have done it now. So let us do a simple numerical. Let us do a simple numerical. Let us do a simple numerical by which we will understand how the multiple parallel surface numericals work and how we can deal with it. Okay, how we can deal with it. Let us suppose we have a numerical like this. Look now. Suppose we have a numerical. And numerical like we have a multiple surfaces. One surface, two surfaces, third surface, fourth one, fifth one, sixth, and so on. Okay, and light is being incident on the first one with some angle, and angle is given to us be how much it is 45 degree, and the refractive index of first one is how much 1. A refractive index of second medium is given to be how much under root 3. A refractive index of third medium is given to be under root 5. A refractive index of fourth one is given to be under root 2. A refractive index of fifth one is given to be let us suppose 1.6. Mu 6 is given to be, let us suppose, 1.96, and so on and so on. Now we have to find out what at this particular refraction, what should be the angle of refraction. So here we have to find out what angle of refraction. So at the particular one we have to find out what angle of refraction. So we don't need to do each and every step of refraction. Now we don't need to do that. Okay, what I can do, simply new one sine of angle of incidence is equals to new 2 sine of angle of refraction. What is new one? Again it is 1. Okay, sine, what is angle of incidence? 45. Okay, great, 45 degree. Where we need to find out angle of r, it is root 2, so I can write here root 2, and sine of angle of refraction. 1 is 1. What is sine 45? I guess it is 1 by root 2 equals to root 2, then sine r. I guess I can write sine r is equals to 1 by 2. Therefore, my r came out to be how much? It is 30 degree. Okay. This is how we can use the upper concept to solve the numericals like this. This is how we can do the numericals to get its answer like this. Okay. Done. Okay. Now we have a second topic now known as refraction through slab. What do we have now? Just write the concept known as refraction through glass slab. Again, the same topic we had discussed in our 10th standard. Refraction through slab. A refraction through what? Slab. Okay. So we have a slab, right? Let's suppose we have a slab. Look now. We have a slab. So we have a slab like this. Okay. And a light is striking at the particular point. Okay. So look, this medium should be rear this ear, and this one should be same as that of ear. Let's suppose the inner one is glass. What will happen now? It will suffer a refraction. Let's suppose it will go like this. Okay. Now at this particular phase, it will suffer one more refraction. It will suffer what? One more refraction like this. Okay. Okay. So let us suppose T is the thickness of the slab. T is what? Thickness of the slab. It is thickness of slab. This is what? Angle of incidence. Angle of incidence. I need to zoom it now. Okay. To get something very clear. Okay. Look. If we don't have any Glass slab, na. So the light should go like this. Light had to go like this. Look. But due to the presence of the different medium, light deviates from its original path. Okay, this is path without deviation. Path without deviation or without what? Without refraction. Okay, and this is what? A path with refraction. Path after deviation. And this is what? This one is my angle R. Okay, this one is my angle R. Look better. If this is my angle R, so this should be the angle of deviation, angle D. Yes, this is what? Angle of deviation. This is what? Angle of deviation. D. Okay, and D is how much? Huh? D is how much? Look now. Look. If this is angle I, this is angle I, so this should be angle I also. This one. Now the whole is angle I. This is R. I think D I can write it as I minus R. So D is how much? I minus R. This is how much? Di minus R. Look now, beta. So this is what? This one, now. This one. This length is known as what? Shift. This one, now. This one I can write it as a what? Shift. This one. Or a lateral shift. This is what? Lateral shift. Done? So look, this angle is 90. Okay. This is R, so this should be also R. So I can do like this also. Okay. This is also what? 90. And this length is also T. This angle is also T. Now what I can do right now? Now look what I can do right now. Look. So what I will write now, that is very interesting now. Look. What should be if we talk about this triangle? If we talk about this triangle, look, this triangle. If we talk about this triangle, this one, okay, and it is, let us suppose, A, B, C. If we talk about triangle, in triangle A, B, C, what is sine D? It is P by H. Okay, what is P? Is it BC? Yes, it is BC. And what is H? It is, I guess it is AB. Now it is AB. So what is AB now? AB is equals to, it is BC divided by sine D. Okay. So it is sine D. Yes, sine D should be BC by AB, right? So what is BC? No. Yeah, what is BC? Okay, BC now. We have to find out BC. So what is BC now? So I can write BC as sine D into AB. Okay. So what is BC? It is lateral shift. Let us suppose it is lateral shift. So I can write it as a lateral shift. So lateral shift came out to be sine D. What is sine D? I can sine at D is what? I minus R. Now we have AB. Now let's take one more triangle, that this one. Let us take this triangle. So in this triangle, what should be cos R? B by H. What is B? It is T. And what is H? H is how much? AB. Therefore, I can write AB is equals to T by cos R. Is it T by cos R? Now put the values in this equation. So I got sine I minus R. What is AB? AB is T divided by cos R. T divided by cos R. So this is the formula for what? Lateral shift. Or you can remember it like this. The lateral shift is equals to t divided by cos r into sine I minus r. Okay, you can remember the formula, the lateral shift. Okay, the lateral shift is what? It is t divided by cos r sine I minus r. This is formula for what? Lateral shift. Done. So we have a numerical from IIT JEE, right? We have a numerical from IIT JEE. Let us suppose we have a numerical, and this numerical is from what? IIT. Suppose we have a glass lab. We have a glass lab like this, and here we have a source. We have a source, and light is striking on this glass slab like this. In this way. Okay, this is my, okay, this is the source. Okay, now what will happen if this angle is alpha? If the angle is alpha, after refraction, what will happen now? It will bend. We know that it will bend. We know that it will bend. So this bend like this. This also bend like this. Now at the particular point, these lines suffers one more refraction. One more refraction. Now they let go like this. Okay, now we have to find out angle between these two lines. Now we have to find out angle between the last refracted light rays. So what should be the answer? We can move it like this, no? I can move it like this. Okay, so the angle should be same. Okay, so the angle would be the same. Done. The angle would be the same only. Clear? Okay, so we have some topics, and we will clear those topics, and we will wrap up the session very quickly. So we have one thing in our mind now, that when light is going from a rarer to the denser medium, it bends towards the normal. And when light goes from the denser to the rarer, it moves away from the normal. What is the basic reason behind it now? Why the light bends towards the normal and why light goes away from the normal? What is the reason behind it? Let's talk about the reason. Let's talk about the reason. Look now. Let us suppose we have an interface like this. This one is my normal. This one is my what? Normal. And light is coming in this way, and it will deviate like, let's suppose it will deviate like this. Angle I, angle R, nu 1 and nu 2. So let us apply the Snell's law. So I guess I need to write now nu 1 sine of incidence equals to nu 2 sine of refraction. This is what? Snell's law. This is what? Snell's law. Okay, now look, if this should be same now, if the left hand side and the right hand side should be same, if the left hand side and the right hand side should be the same, clear? Then what we can do, let us suppose mu1 is the refractive index with the small value. Okay, smaller is having a very small value, and this one is a very big value, a large value. So if this is small, this one is large. So to balance it, this side should be large and this side should be small. Okay, look now, if I write 3 into 4, if I write 3 into 4, so if I have to balance this equation now, so what I can do, I can write 6 into 2. Okay, I can write 6 into 2. That means, look now, this one is small, then large. This is large, small. This should be the same. Then only what we can say the Snell's law is applicable. Clear? So if nu one is small, that means it is a rarer one. It is what? A rarer one. If nu two is large, so this is a denser one. This is what? Denser one. Look now. So I should be more and R should be less. So if this should be less, so this should be what? Bent toward the normal. That's why if light is going from rarer to denser, if light is going to rarer to denser, your light ray bends. Light ray bends what? Towards normal. It bends towards normal. Clear? It bends towards normal. And let's suppose nu one is more and nu two is less. So in that particular scenario, let us suppose now we have a different one also. If let us suppose we have what? Nu one sine I, we know it should be equal to nu two sine R. If now nu one is large, a big value, and nu two is what? Small value. So to make these things equal, now this should be what? Small, and this should be large. It is only possible when light goes, if we are moving from what? Denser to rarer. Denser to rarer. So this should be large. So we can write that it goes away from the normal. Your light ray goes away, away from the normal. This is the real reason behind why light bends towards the normal and why light goes away from the normal. Clear? Very easy. Okay. One more thing. One more thing. So we know that speed, that is v. V is equals to frequency into wavelength. We know it. One more thing, that speed is equals to frequency into wavelength. Frequency into wavelength. You have to keep one thing in mind, that frequency is a property of source. Frequency is property of source. Your frequency doesn't change while going with refraction. So frequency is a property of source, it doesn't get changed. So that color is also what? A property of a source. So while refraction, neither frequency nor your color will get changed. Only speed of light and the wavelength of the light ray will change. That means your speed is directly proportional to the wavelength. As your speed changes, your wavelength also changes. Clear? Okay, look now. Look now, beta. When light is going, when your light goes from, let us suppose it goes from rear to denser. Light goes from rear to denser. What will happen? We know that its speed decreases. So therefore, it is wavelength also decreases. Okay, it is wavelength also decreases. Wavelength also decreases, right? So if your speed decreases while going from rear to denser, if speed decreases, so wavelength also decreases. And if we just change it, if light goes from denser to the rarer, speed increases, optically rarer medium, that medium in which light speed is more. So if speed increases, so wavelength also increases. Wavelength also increases. Okay. Okay, look now. We also know that now, if light, so what is the condition for no refraction? What should be the condition for no refraction? Let us suppose that case also. Let us do that case also. If we have an interface like this, if we have an interface like this, look now, we have an interface like this. Okay, and this is my normal towards it. And you have to keep one thing in your mind, that all angles are being measured from the normal. Okay, if my light is coming in this way, okay, so let's suppose this is nu one, this is mu two. Clear? And we know that this is incident light ray. This is what? incidental light ray. We don't know while there will be any kind of deviation of light or not. Let us write the Snell's law for it. So I guess Snell's law is nu1 sine I equals to mu2 sine R. We know it. Okay. Look, mu1. What is sine R? I guess here, if you look into now, the angle I equals to 0. Okay. So I can write sine 0 equals to mu2 sine R. So I can write mu1. What is sine 0? It is 0 equals to mu2 sine R. I can write therefore mu2 sine R is equal to 0. So mu2 cannot be equal to 0. There, so I can write what? Sine R will be equal to 0. Therefore my R should be equal to 0. Okay, so the light will go along the same path without having any deviation. Without having any deviation. That simply means if light is coming with a 0-degree angle, it will pass with the 0-degree angle, that is no deviation at all. That is no deviation at all. Okay. Okay, let us do one numerical. If we have a glass slab, if we have a glass slab like this, okay, and the glass slab is having some kind of thickness T. So it is having some thickness T. Okay, and light is falling on the screen, this one normally. I guess it will pass through this glass slab without any deviation. This is what? Incidental light ray. There is ear. So if light takes time t, to cross this one, so now find out the value of time t. Find the value of time t. We know that speed is equals to distance by time. We know that speed is equals to distance by time. We have to find out time. So time is equals to distance by speed. Time is how much? Distance by speed. What is distance? I guess distance is t, so I can write t. What is speed? Speed of light should be v. Clear? But also we know that refractive index means speed of light in vacuum, speed of light in medium. So I guess I can write v came out to be c by nu. So therefore I can write t whole divided by c by nu. Therefore time to cross this glass slab would be nu into thickness of glass divided by c. Okay, time to cross this glass slab of thickness t, it is equal to the refractive index. Nu is refractive index of this one. Huh? The refractive index of this glass slab multiplied by the thickness divided by speed of light in the vacuum. Speed of light in the vacuum. Done? Easy? Any doubts? If yes, then you can let me know now in the chat box. If after the class you have some doubts, you can just post your doubt in the Telegram group, right? And that the link of Telegram group is given in the description of the channel. You can get that link. Okay, let's do one last numerical. Let's do one last numerical. One last numerical. Okay. Suppose we have something like this. Suppose. So we have something like this. Okay. Interface. And this is what? A normal to it. This is what? Normal to it. And if my light is coming in this way, look. Some part of light is going in a refraction. Some part of light is going into the refraction. Clear? This is angle of incidence, angle of reflection. This is angle of refraction. Angle of refraction. And we know the angle between these two should be 90. This is angle 90. Okay. and the refractive index of this one is nu. So we have to find out this angle nu if the angle of incidence is going to be 60 degree. Okay, how we can do it? Look better. How we can do it? We know that this is 60, this one is 60. So by the angle, by the laws of reflection, so this side should be also 60. Yes, so this angle would be the 60 degree. And this is my total line. And the angles on the line should be 180. So it is 60 plus this 90 plus R is equal to 180. Okay, it is 150 plus angle of refraction equals to 180 degree. So therefore, my angle of refraction came out to be how much? 30 degree. Angle of refraction came out to be 30 degree. Clear? And this is ear. And we know that refractive index of ear is 1 only. So I can use here what? Snell's law and state that nu 1 sin r, sin I, sorry, equals to nu 2 sin r. Nu 1 is 1, sin I is sin 60 degree. Nu 2 we don't know, sin r is sin 30 degree. What is sin 60? It is root 3 by 2 equals to nu 2 sin 30 is how much? 1 by 2. 2 to cancel out. Nu came out to be how much? Nu came out to be root 3. Okay. I guess you understood the same concept like this one. So what we had discussed in this session. So if you can check here now. So firstly we discuss what? We discuss what is refraction here now. What is refraction? So yeah, what is refraction? Okay, then the kind diagram for refraction. Now what is refractive index? What is absolute refractive index? Relative refractive index? How we can write the refractive index in terms of speed of light? What is laws of refraction? Multiple parallel surfaces, we done it. Refraction through glass slab. What is the lateral display? What is lateral shift? That is sin I minus r t by cos r. Then we done some numericals. Then reason for why light bends towards the normal or away from the normal. Then we discussed the effect of speed and the frequency in the wavelength in the refraction. Okay. Then we had the kind of one numerical, two numericals. Okay. Then tomorrow we will be discussing what? Lecture number 2. Okay. So I guess you have enjoyed the session, and bye from my end and good night from my end. Okay. Thank you, Veda.